So, let me run through that one more time. Okay. Print all primes less than 100. Number equals 2. While number is less than 100, do something. Number plus equals 1. Okay, so far my program is correct. Everybody's okay with it? And seriously, so far my program is correct. Okay, do something clever. Okay, I'll skip the, I won't do it in excruciating detail. Might B prime is true. Mumble, mumble, mumble. If might be prime, print number, and then go on. Okay? So, no, but I believe this program is correct. Okay? It might be a prime, something, something, something. If down here, it still might be prime, we're going to print it out. Okay? Or we think it is prime, if you want a really long variable name. We think it is prime is true until we can prove otherwise. Try to prove otherwise. If we think it is prime, print it out. So why don't I change it to that? There. Okay? We think it is prime is true. Counterexample. If we think it is prime, print it out, and then go on to the next number. Everybody okay with that? Okay. Now let's come back into the middle. By definition, it's prime if it can't be divided by anything between 2 and itself. So, what are we going to call this variable? Divisor equals 2. While divisor less than number, mumble, mumble, mumble. Okay? So, we're going to test each number from 2 up to number. Okay? Mumble something, some kind of test, and then move on. Okay? Again, that's just a very simple expansion of what I just did. So now we come back and fill in the mumble, mumble. Okay. If, more mumbling, we think it is prime is false. So we're looking for counterexamples. Okay? And if we find one, then we think it is prime to false. Okay? So now let's come back and say, okay, does divisor go into number evenly? Well, that is where we say if number remainder divisor is 0. There's no remainder. Then we think it is prime is false. There's other ways we can do that calculation. There's lots of ways we can make this program more efficient. We're going to ignore all of that for now. I assert without proof that this is pretty much the simplest program I could write that produces the right output. It's not the most efficient, may not even be the most readable, but I believe this program should do the right thing. Here's the kitten. How many people think the kitten's going to be happy 30 seconds from now when I try running the program? Okay, I have one person who's willing to risk the kitten's life. 2, 3. Okay, green cards if you believe the kitten's going to live through the next minute. Okay, red cards if you think the kitten's life is at risk. Oh, sorry, yellow card if the kitten's life is at risk. Red card if you know why. Okay, I've got a yellow card. I've got 2 yellow cards. Okay, I've got a green card. I've got most people not voting. Okay, green, green, green. Come on. What's green, yellow, red? Everybody gets to vote.
You didn't do it. I don't know.
You didn't? Yeah. You just, okay. Anybody? Okay, got a bunch of yellows, a bunch of greens. Everybody should be showing a yellow card at this point. Any program that has not been tested is wrong. No other attitude, thank you, no other attitude is going to get you through this. If you have not tested it, it is wrong. Right? I'm a pretty good programmer. I've worked with many who are better, but I'm not bad. I can earn money programming. Right? Even during a recession. I can't remember the last time I wrote something that was more than 3 lines long that worked perfectly the first time it was run. I really can't. Human beings are fallible. You build your process around that. Nijni ne provizhni. Trust, but verify. Okay? I think this is worth running. Okay? That's about as much as I'm willing to say right now. So I come back here and I say Python first.py or primes.py. Woohoo! I've got output. I must be done. Okay, is it right?
Yes.
Is it? Are you sure? Are you really? You've read every single number there, and you know that none of them are non-primes. No. It looks about the right size. Okay, you know. Okay, so this brings us back to one of the fundamental challenges in scientific programming. Something that people in building websites for shopping malls mostly don't have to deal with, and it makes your lives more difficult. In this case, I can go Google for a list of the first 100 primes and do copy-paste and try to compare. Okay, what if it was the first 10,000 primes? How are you going to check the output of something that's supposed to produce the first 10,000 primes? How are you going to check the output of a program that is supposed to be doing some audio processing? You've got a 15-second wave file. You've got a bunch of filters that you're applying. Here's the output waveform. How do you know if it's correct? Well, if the output waveform is completely flat, it's probably wrong. Right? No, that's okay. Obvious failures are easy to detect. That's why they're called obvious. What if the output is only slightly wrong? Say, just wrong enough that your t-test is going to give you the wrong answer. How do you detect that? In scientific programming, most of the time, if you know what the right answer is, you won't bother to write the program. Why would you if you knew what the right answer was? You would publish the result and move on. Right? You very rarely come back and do the same thing over and over and over again. You might run the same program, but it'll be with different parameters, a different experimental regime, different subjects. Something will be different, and you don't know what the right answer is. In banking, the right answer is whatever the Basel II Accord dictates. There are, last time I checked, 17,000 odd pages describing what is supposed to happen if you do a currency transfer across a national boundary that crosses the international date line on time when one or the other of the corresponding parties is switching because of daylight savings time and there's been currency fluctuations in a third market that's being used to arbitrage the difference. Yeah, you think I made that up? I had to test that case. At least they'd written it down. Right? In excruciating detail. Yeah, there's a reason I look old and tired. But at least they'd written it down, and I didn't have to think about what the right answer was. Somebody was telling me. In much of the work that you do, if you know what's supposed to happen with instrument recognition in this, I'm going to pick on you, musical instrument recognition, yes, if there's only a trumpet playing, your program should say trumpet, right? If the drummer is in the middle of a solo, it should say drums. What should it do for a balalaika? What should it do for bagpipes? What should it do what does it do for some instrument you've never encountered, or when there's noisy signal, or when there's several instruments playing, or what do you do when you don't know the right answer? You can say that you don't know the right answer, sure. But then how do you test that the program is doing the right thing, that it's saying I don't know for the right reasons? If you guys don't know what the output's supposed to be, you can't test. Right? I mean, your answer was, well, I listened to the output. Okay, no, that's fine. In some cases, in the video game industry, that's fine. The graphics doesn't have to be right. If nobody notices that the graphics is glitching in some cases, you don't care. Right? You really don't. It's playable. I can make money from this. You're in a different